Kia ora class. Today we're talking about the biomechanical principle of balance and stability. The learning intention for today, we are describing the three components of balance and stability and applying those components to the performance of physical activity. So what is balance and stability? Let's start here. Balance is the state of having your weight spread equally so that you don't fall over, pretty straightforward, or the ability to move or remain in a position without losing control or falling. Now that sounds quite relevant to the movement that may be going on in physical activity. And stability is the quality or state or degree of being stable. So how stable are you? How much can you stay in the position that you want to be in? And that is that balanced position. Those definitions come from Merriam-Webster, by the way. So, why is balance and stability important? That is, what can it bring to your physical activity performance? Well, a performer with greater balance and stability will see some of the following benefits when they participate in physical activity. First thing, it'll be harder for them to fall or to be pushed over. They'll have better control and accuracy when executing movements and skills because their body is stable to begin with when they start executing that skill. They will have a better ability to change directions quickly, and that's what we call agility. So if they're stable and balanced, they'll be able to move in any direction quickly as opposed to being unbalanced where they would have to correct their balance first before they could move off in a different direction. And lastly, there's less risk of being injured if you are more stable and balanced. How can we apply balance and stability? Well, the three principles that we talked about in the learning intention are as follows. Base of support, center of gravity, and line of gravity. Those three things are the three components which make up balance and stability, your overall balance and stability. Let's go through one by one. Base of support, sometimes abbreviated to BOS. Your base of support is the area between all parts of an object and contact with the ground. We can improve our overall stability by increasing the size of our base of support. So in this example here, the parts of this object, the parts of the person in contact with the ground, are the feet. In this first figure here, figure 1, you'll see that the feet are quite close together, which means that the base of support is this sort of small area here. Okay, that small area that's sitting on top of the ground. Now in figure 2, he has increased his stability by increasing the size of his base of support. We can see here his base of support is much bigger. The area is much bigger. Next, center of gravity. This is the point within an object or sometimes outside an object where all parts of the object are equally balanced around. It is an object's center of mass. If you can imagine picking up an object at a single point and you picked it up, it wouldn't spin, it would be perfectly balanced in all ways if you could pick it up by that point. We can improve our stability by bringing the center of gravity closer to the ground, that is, lowering the center of gravity. And it's also worth noting that we need to compensate for any part of the body that moves away from the center of gravity by moving something else in the opposite direction. So say for example, if I put my arm out like this, my center of gravity has shifted a little bit, shifted out to the side. To compensate for that, I would need to put my other arm out, and that would bring the center of gravity back in the middle because I've compensated with an opposite movement. Here we can see a diagram of center of gravity. This black dot in the middle of the first guy is resting center of gravity, but if he moves his arms up, his mass starts, his average mass, his center of mass moves up with that. Yeah, so you can see the center of gravity there has moved a little bit higher, and in that third figure there he's rolled over. And in this case, the center of gravity, the point at which all parts of his body are balanced, is actually outside of his body. You can see he's also had to compensate because he's put a part of his body forward. he's had to sort of stick his butt and legs out backwards to compensate for that, and that's that point at the bottom there. Alright, the third component of balance and stability is line of gravity. The line of gravity is the path directly down from the center of gravity into the floor, straight down. In order to maximize our balance and stability, we need to keep our line of gravity going straight down through our base of support. So if we remember, the base of support was the area that the points of contact make on the floor. So we want our line of gravity going straight through the middle of that. That will be when we are most stable. We can see here in this diagram, the center of gravity are the two red circles, okay, and the line of gravity goes straight down. This person is said to be reasonably balanced because their line of gravity is straight in the middle of their base of support, and the green arrows sort of show the edges of that base of support. However, in this diagram, this person would be quite unbalanced. You can see that their base of support is quite small, and the line of gravity is way outside of the points of contact with the ground. Okay, and if he didn't move any other parts of his body, he would just straight fall over. Yeah. So to summarize, we can improve our balance and stability in the following four ways. Creating a larger base of support, lowering the center of gravity, using opposite body parts to compensate for movements either side of the center of gravity, and keeping the line of gravity going straight down through the middle of our base of support. Hope you've enjoyed that, guys. That was the biomechanical principle of balance and stability.